So today when we talk about the tangent ratio, one of the things that we've asked you to do is you're going to go and take a look at this ramp, right? And with this ramp, the stage is always going to be 4 meters high, but we're going to change the base of the ramp. So we should have 3 different ramps. And what I want you to do right away is I want you to label each ramp A, B, and C. Now that I've done that, what I need you to do is I need you to tell me how to calculate slope. Yep. Yes, you said rise over run. Awesome. So, and we're going to do this to 2 decimal. We're going to go and calculate these slopes to 3 decimal places. So when I calculate the first one, I'll just show you right away. We've got 4 over 22.69. And once we've done that, you're going to round your answer to be 0.176. And what I want you to do is do the same for the rest, for the last 3. Okay? So now, so in the past, what we did was when we were trying to find, say, the sides of a triangle, we always related a bigger triangle to a smaller triangle. Now, I've been alluding to this fact the whole time, right? Anytime we have similar triangles, all of the angles are identical, right? Now, my question for you is this. Wouldn't it be amazing if I was able to find some function that would relate the angle of any similar triangle to another similar triangle to give you the ratio that will allow you to find one of the sides? Now that would be awesome, wouldn't it? It would save you a lot of time. And this is what we have entered into today. We are going to take a look at this thing called the tangent ratio. The tangent ratio on your calculator looks like this. Tan. Okay, so look for it on your calculator. You should see it. Now, here's the rule. You take a look at this 10 degrees, right? That 10 degrees is going to give you the ratio of the sides for the opposite and the adjacent angle. The adjacent angle is the angle that just touches the side of the angle. Right? And the opposite is directly across, and we know that this is our hypotenuse. Do we agree with that? No, that's good. So, if I asked you to calculate the tangent of 10 to 3 degrees, to 3 decimal places, you're going to get something that looks like this. You ready? First of all, you're going to start by relating the fact that tangent is equal to opposite over adjacent, and then you just go and label your triangles accordingly. Right? And then what you do is you literally just calculate the tangent for us. So if you calculate the tangent of 10, look at that. What number is that? The number is 0.176. And it literally matched what we had calculated up here. So that's going to save us a lot of time. Now what I want you to do is calculate the tangent of 25 for part B, and then I want you to calculate the tangent of 60 and see if those things all match. Calculating the rest of these, you're going to get tan of 25 is 0.466, and tan of 60 degrees gives us that. Notice they're identical. Because they're identical, that would allow us to either find a side or find an angle. If I know 2 sides, I could find an angle. If I know a side and an angle, I could find another side. Holy jeez, we've got some serious math here going. The rule that we're looking at today is we've got tangent is equal to the opposite over the adjacent, right? The opposite leg of the triangle divided by the adjacent side of the triangle is equal to this thing. So what this allows us to do is it allows us to solve for something, either solve for a side or solve for an angle. It's going to be amazing. Let's take a look at this next problem. Flip to the back side of your sheet. Now, here's the rule. It says This question is saying find tan of theta for each triangle. And what they're really saying is just to find the ratio. This one is just to say find the ratio. If you see something that says find tan of theta, they're not asking you to find the angle. They're just asking you to find tan of the angle. So I know for this one, I've got tan of theta is equal to O over A. So we start with that. Right? Now, what we want to do is we want to label all the sides. So there's my theta. So that means this is my adjacent because it's the angle that is directly beside my angle. And then the theta, this part over here, is my opposite. So when I write this out, we're going to say tan of theta is equal to, well, it's just 5 over 12. And we're going to express that to how many decimal places did I say? 3. So we'll express it to 3 decimal places, which gives us 0.417. When you calculate tan of theta is equal to O over A for this next problem, you're going to label all the sides. Make sure you also label your hypotenuses as well because we'll be using those in the next couple of days. So when we go and calculate this, we're going to get tangent of theta is equal to 6.8 divided by 4.5. Calculating tan of theta, you're going to end up with 1.5111. For this next problem, label all your sides again. Now, once you've labeled your triangle, as usual, start with tan of theta is equal to O over A. And there's your answer for each one. Larry's laughing. Now, what I'd like you to do is I'd like you to take a look at these ratios. When I ask you to find the tangent ratio of any degree, all I'm asking you to do is tell me what the decimal is, okay? And what you're going to do, calculate it to 4 decimal places for me. So the first one, tan of 0 is always 0. But tan of 35, that's a different number. It's a different beast altogether. Calculate it. Punching in tan of 35, you're going to get equal to 0.7002. And then tan of 45 is 1. Think about it. If you have an isosceles triangle with a 90-degree angle in between it, both sides are the same, aren't they? What is 5 divided by 5? 1. Opposite over. Get it? All right. Now, if I have tan of 72, calculate. What do you get? Excellent. 3.0777. All right. And then tan of 90, undefined. Sometimes you'll see error on your computer or calculator. When we do this problem, it says find the angle of A and B for the right triangle. Now, don't do trig for everything, all right? You can use trig for one of the angles and then use the interior angles of the triangle, of the right triangle, to find your other angle. So let's do that right now. First thing that you're going to do is you're going to label the angle that you're going to look for. I'm going to call that theta. All right? And now that you've labeled that theta, you can label all your sides as adjacent, hypotenuse, and Yep. The cool part about it is the fact that you can choose which one you want to start working with. Maybe you don't like working with the angle on the top. Maybe, I want to change that theta and move it down here. You could have done that instead, but then you'd have to change your sides. So now, let's say we start. When we start, what we're going to do is we're going to start by saying tan of theta is equal to opposite over adjacent, O over A, right? Now we start filling in all the information that we have here. So O over A is just 3 over 1. But we still don't know what tangent of theta is. So I'm going to show you how to get theta by itself. In mathematics, we call this thing the inverse. I know. We call this the inverse of tan. And in order to access that on your calculator, all you have to do is either hit the second function and then shift, and then tan of bracket 3 divided by 1. Now, it could have been 3 divided by 5, and you'd still come up with the answer, right? But what that does is it generates what the angle is. And in this case, it's going to be 72 degrees. And I want you every time to calculate to the nearest degrees, because you know what? There ain't nobody out there that can go and read a protractor and find that it's like 75.2 degrees. I can't do that, right? We're just going to go with 72 degrees. Now, once we've done that, we have theta is 72. So I could go and rewrite theta and put 72 degrees here, right? I can find my angle here. Let me call it, are you ready for this? I'm going to call it tau. Tau is going to equal the following. Where'd it go? Tau is going to be 180 minus 90 minus 72, which gives us 18 degrees. And have we solved the triangle? This is the best thing because there are right angle triangles, and we can use this to find any right angle triangle side or angle. Okay? Later on, in about 3 or 4 classes, we'll do something that will accommodate for any kind of triangle. But right now, we're sticking with right triangles. So when we calculate tan of a number, we're finding the ratio, but when we calculate tan inverse, we're always finding the angle. Oh, yes. All right, so for the next problem, we're asked to find the length of a side expressed as a decimal correct to 2 decimal places. So let's take a look at the first problem here. So our first problem is this triangle, right? Now, the trick is to recognize that I have 2 sides here, right? I have an unknown side, and I have a side, and I have an angle. The moment I see that, I know I'm going to use tan because I got 2 sides and an angle. Okay? So now, once you've done that, you need to label all your sides as opposite, adjacent, and hypotenuse. Now that I've done that, you need to set up your tangent ratio. So your tangent ratio is tan of theta is O over A. And all we're going to do is fill out all the stuff that we know. So when we fill it out, you're going to get tan of 21 is equal to, tan of 21 degrees is equal to what? Right, x divided by 8.3. We start off by multiplying both sides by 8.3, right? And that gets rid of the 8.3 on the bottom of x. So now we're left with, no, you go 8.3 times tan 21 equals x. Now, yes, there is, because some calculators, you guys don't realize that you need to put a bracket after you put your answer in to tan. It's like a function, right? It's like you're substituting a number into it. So tan needs to have a bracket around that 21, right? So now that you get that, you're going to end up with this as your final answer. 3.19 is your answer. Okay? So now what I'd like you to do is I'd like you to work on this triangle. See what you can do. Use cross multiplication or division or anything to solve for x. Now for this next equation, we're going to start with this triangle here. The only things we're concerned with are the opposite and the adjacent. Now you're going to start by saying tan is equal to O over A, and then we substitute accordingly. So we're going to get tan of 75 is equal to 40. But now x is on the bottom of this, so what we're going to have to do is we're going to have to multiply both sides by x. In doing so, you're going to end up with this. X tan 75 is equal to 40. Now we're going to divide both sides by tan 75 to get rid of the tan 75 that's attached to the x. So in the end, you're going to end up with this. X is equal to 40 over tan 75. Punch that in your calculator, and you're going to get the following. Tan is equal to 10.72 centimeters. Now, what I'd like you to do for homework is this.